Hello everyone, so welcome to my channel. Today we are going to look at step by step on how to make a bill of quantities or cost estimation from foundation up to finishing. So this video is courtesy of Margaret, uh, who just inboxed me and asked to kindly prepare for the step by step preparation of bill of quantities. So because it will take a lot of time, we'll split into different sections. Each video covers each section of the building. So let's start with foundation and slab. Without wasting time, let's start with looking at the plan and calculating the perimeter, and also later we calculate the area of the plan. So as you can see, we have this plan. We have the measurements 10700 by 11600, the maximum lengths. So you need to calculate this length. You add this, you add this, you add this, this one, this one, this one, this one, and this one, to find all the walls, the perimeter of all the walls, not the outside wall alone, all the walls. So if you can add all these measurements, I'll leave you the notes there. So if you can add all these measurements, you will get 78,600. I don't want to waste much time on calculating. So we'll get 78,600 on all the perimeters of all these measurements. So if we get 78,600 millimeters, we then divide by 1,000 first, so that we can get in meters. So 78.6 meters. This one is the perimeter of all of this plan. So if we get the perimeter of all this plan, we need to calculate the number of stones that can be used to make the foundation. So the number of stones used to calculate to make the foundation will be 78.6 divided by the size of the stone, then times number of layers or courses for the stone. So for our case, we will use a stone, a standard stone of 400 millimeters by 300 by 200 millimeters. So because 400 is our length, this means it is 0.4 over meter. So, and normally in standard, after cleaning up the area for the building, so we'll know that we'll go at around 0.9 over meter for standard foundation. Standard foundation for only the single story building. There is no not for the story building. So for the normal houses, the 2-bedroom, there is no story. So we'll go for 0.9 meters for a good soil, maybe the loamy soil. If you are in other areas where there is maybe different soil, it will determine the length depending on the strength of that soil. So for our case, we'll use 0.9 meters. So meaning 0.9 meters, and our stone was 400, which is 0.4 by 0.3 by 0.2. So 0.3 is our height. So this one is our length and this one is our height. So what we do, we now come and say that 78.6 over 0.78.6 divided by 0.4. 78.6 divided by 0.4. The length now, to get the total number of stones to cover all this perimeter. So all this perimeter will give us around 196.5 stones. That's per course. per or per layer. After this now you need to know that we said we need 0.9 over meter, 0.9 over meter for the total length of the total height of the foundation. So for our case it is 0.9 divided by 0.3 over meter, the height of the stone. So that gives us around 3 layers. So if we get 3 layers now, the next thing we are going to do is we say 196.5 stones per layer. So it is 196.5 stones over or divided by 3 layers. Sorry, times the 3 layers, because this one is 196 stones per layer times 3. So giving us, so it will give us a total of, so let me calculate. So 196.5 times 3, it will give us 589.5 stones. So it will give us 589.5 stones. So this one will give us this one is approximate 590 stones for foundation. So we finished on number of stones, but now give an allowance of breakage. So we'll give an allowance of, let's give 25%. So 590 times 125 over 100. We have given allowance of 25%. So it will give us, so it will be 590, 125, 5 divided by 100, multiply by 590. It will give us 737.5 stones. 737.5 stones, which is approximately 738 stones. 738 stones. Foundation. So this one is foundation stones. So we are done with it. We'll come and calculate the price later. So let's now go to the sand, and we need the sand and cement for the concrete for joining the stones. You know, we'll need the concrete for joining the stones. So for sand and cement, we know that we use the ratio of 1 to 3, because here we don't need the hardcore or the kokoto. So the ratio of 1 to 3. So 1 to 3 for the sand. So this one is cement, and this one is sand. So assuming now we'll take a thickness. We'll take a thickness of 200 millimeter between the stones. So between the stones, sorry, 200 millimeter is too big. Sorry, too big. So we'll take around 20 millimeters, the standard 20 millimeter thickness for the stones. So 20 millimeters is like, in terms of meters, it will be 0.02 meters. 20 over 1000, so it will be 0.02 meters. So between these two stones, as you can see here, we will need a 20 millimeter, 0.02 meters, millimeters. So we'll need 0.02 meters thickness. And also remember, you will need the thickness also for this side. This one is the stone. I guess you are seeing. So as you can see, this one is 0.02 meters per. So per stone now, we will be taking this stone, will be taking the bottom and the side. This one bottom and the side. So meaning, and the side, meaning every stone will take two sides. So it will be, let's now calculate. So the thickness is 0.02 millimeters times the number of stones. So the number of stones in our case was 7.7 for the breakage, but now it was 590. So it is 590 before we added the allowance for breakage. So it is 590 stones times the two sides, the bottom and the side. Each stone will take two sides, so it will be 590 times 2. So it will give us, so let's calculate 0. times so times 0.202 millimeters times 590 stones times two sides. So but now before we go to this point, as you can see, so before we go to this point, we need to calculate now to change in terms of volume of the thickness of the concrete, the thickness in terms of volume. So let me take you back a bit so that you can all understand. So this one is the thickness, and you know that this one is our stone. So this one is 400, is 0.4 by 0.3 by 0.2 by 0.2 the thickness and 0.3 the height. So in terms of volume, we said it is 0.02 thickness, the thickness of that concrete, times the distance. So if it will take 0.2 the thickness, which is in our case it's like the height of that concrete, so the thickness T times, now it will cover the whole length of the stone. I guess you understand that. So it will cover the whole length of the stone because we are covering the stone. So times 0.4 times, now it will not cover the height, but it will be covering, for our case it will be covering the width for the top. So it will be covering the width. So our width is 0.2. So for one side, that's for one side. So meaning, so this one will give us so it will give us 0.02 times 0.4 times 0.2 times 0.2. So this one will give us 0.0016. meter cubed per side. So in our side it is the top. So for our case it is at the top. But now for the case of the side, this end now, because we are, so we found 0.000028 meter cubed per stone now of concrete per stone. So we'll need now to calculate for the total number of stones. So it will be 0.0028 times the 590 stones, which will give us 1.652 meter cubed. Hope we are seeing. So this one is the volume of the concrete. And you know, for us to make this, we'll need a ratio of 1 to 3 of cement and sand. And before then, we need to know now the density. So because we have the volume, we need to know the density. So the density of cement is 1442, and the density for sand is 1600. So what we'll need to do is we'll use the ratio now to get the volume per each, the volume of each, the sand and the cement in terms of ratio. So it will be 1 over the total now for multiply by its density, which is 1442, by the number of the volume now, which is 1.652 meter cube. So it will give us total now 591. So it will be, let me calculate. So this one now will give us 595.546. So this one is 595.546 kilograms now, because we've multiplied the volume and density. So this one is the mass now of the cement. Then, so because we need to convert, so 595, we need to calculate 595.546. You now divide by the 50 kilogram back to get now, so it will be divided by 50 kgs to get the number of bags. So it will 11.91, which is 12 bags of cement. So we'll need 12 bags of cement. Then now add so 12 packs of cement. Then now add, let's say, sand. So it will be 3 over 4 pi. Its density is 1600 times the number of volume, which is 1.652, which is, so it will give us 1982.4 kilograms of sand. So this one will give us 1982.4 kilograms. That's just approximately 2 tons. So we are done now with the foundation. So we go to our list now. We can come before we prepare our list now. We'll come and see we'll need. So before we do this, let's add 25% of wastage, or we'll just come and add at the final stage. So let's add these ones. So add 2 tons plus 25%. So it is 125 over 100 times 2000 equal to, so 1.25, so it will give us 2500. So it will give us 2500, which is 2.5 tons. 2.5 tons of sand. And if you add 25% of 12, so 25%, so it will be 1.25. So it will give us 15 bags of cement. So it's as simple as that. So 15 bags. So let's now come into summary. So we will need now our materials. Now we will need 16. We'll need 16. Sorry, we'll need building stones, or the foundation stones, which gives us 590. So it was 590. So foundation stones was 500 plus 25%, so which gives us 398. 738 stones. And then cement is equal to 15 bags. We have 2.5 tons of sand, and then add labor, which is 25% of the total cost. So let's see now the material cost. So item, so we can write just item, quantity, description first, quantity, amount, and then total amount. So item number one is, let me use this pen so that it can be very visible. So item number one is stones, foundation stones. Size is 400 by 300 by 200. Quantity is 738, and then amount per stone is 65 shillings, and then total number, it will be 65 by 7, so it will give us 47,970. Then next item is cement. Just write here cement. How many bags? So it's just, let's use 32.5, the strength of this, and then quantity is 15 bags. Amount, so it is 800 for the case of Kenya shillings, 800. Then the total amount is Kenya shillings, 800 times 15, so it is 800 by 15 is equal to 12,000 Kenya shillings. 12,000 Kenya shillings. And then we need 2 tons of sand. So sand, so just normal sand. Quantity is 2.5 tons, and then amount per ton is around 800 Kenya shillings in Kenya. For total 2.5, that is 1600 plus 800. 2.5 5 times 800, 2,000 shillings. So it will give us 2,000 shillings. Then now let's add now total, so that we can calculate 25% of labor. So 47 So the total now, so that we can get labor cost, which is 25%. So 25% of the total, which is 61,970. You add this 61,970. 25% will give you 24,788. So 24,788, and then total now will give us 86,758 Kenya shillings. So that's now how to calculate the bill of quantities or cost estimation for foundation. We added labor, we've added everything. So foundation for this 2-bedroom, as you can see here, foundation for this 2-bedroom is just around 86,758 Kenya shillings. Remember, after the all other sections, we'll add up and add miscellaneous spendings also, which will cover up all of them. So the next thing is slab. We'll now come and calculate the slab. So the slab now is the next topic. So kindly check on my next video. This is the slab I'll be posting today. So kindly check on the slab. So please subscribe, kindly like, subscribe, and leave a comment if you need any clarification, or if there is anything you can ask, just you are free to ask. Thank you so much for your attention. Kindly please subscribe so that you can get for the next steps. So we are going for slab, then if we finish slab, we'll go for the wall, and then we continue. Thank you so much.